Hello guys, welcome to my channel Civology, the study of civil engineering. Today in this video we are going to discuss the types of loads. Basically structural loads are categorized as vertical loads, horizontal loads, and then there comes special loads. So guys, in this video we are going to discuss the 10 types of loads that a building may experience during its lifespan. Okay, we will discuss these loads one by one, but before we start our today's topic, if you are new to my channel, you are requested to please subscribe it and don't forget to press the bell icon to get video updates. So let's get started. Why it is important to know the type of load and intensity of load? Because without defining what load acts on a structure or building, the engineer cannot verify the structural element. If the loads are calculated incorrectly, the safety of the building is at risk, or the structural elements are dimensionized inefficiently, which results in high cost. So it is quite important to get the calculation of the loads right. Okay, so guys, let's proceed towards the categorization of loads. The loads are basically categorized as vertical load, horizontal load, and special types of loads. Okay, vertical loads may include the live load or imposed load, dead load, and snow load. Okay, because the direction of application is downward or upward. Okay, as you can see over here, live load acts downward and dead loads also acts downward, and the snowfall or the snow load also acts downward. So these types of loads are categorized as vertical loads. Horizontal loads may include the wind load and earthquake load. Okay, as the wind load acts laterally, as you can see over here, it may act in this direction from left to right or from right to left, and earthquake load is also considerable when its movement is horizontal. Okay, vertical movement of earthquake load is generally neglected. Okay, then there are special types of loads which may include the load combination, accidental loads, thermal load, settlement load, soil and fluid load. So now let's discuss these types of loads one by one. The first one is live load, or it is also called as imposed load. It is one of the major load in the design. A load that is subject to vary over time is referred to as live load or imposed load in civil engineering. The load's weight fluctuates or changes position while people are moving through a structure. For example, anything in a building that is movable and not attached to the structure may result in a live load. As you can see over here, people and furniture result in live load. Okay, that is not attached to a structural member and it is movable, is called as live load or imposed load. Live load may be described as operating on a concentrated region, which is also called as point load, or it may also act as uniformly distributed load. The second type of load is dead load. Dead loads are permanent or stationary loads, okay, which are transferred to structure throughout the lifespan. Dead load is primarily due to self-weight of structural members, permanent partition walls, fixed permanent equipments, and weight of different materials. As you can see over here, the dead load mainly includes the structural members like the weight of the beam, weight of the slab, weight of the column, weight of the stairs, which are fixed and which are transferred to structure throughout the lifespan of the building or structure. Each structure's dead load are determined by multiplying the unit weight material by the volume of each segment. The third type of load is snow load. These types of loads are considered only in the snowfall places. This is the weight that snow buildup may impose on the building. Large amount of snow may build up and place a significant strain on a building. The fourth type of load is wind load. In structural design, wind load must be taken into account, particularly if the building's height is more than twice the dimensions measured longitudinal to the exposed wind surface. For low-rise buildings, say up to 4 to 5 stories, the wind load is not critical because the moment of resistance provided by the continuity of floor system to column connection and walls provided between columns are sufficient to accommodate the effect of these forces. So basically, wind load is considered for high-rise buildings. Okay. Generally, low-rise buildings, or you can say up to 4 to 5 stories building, wind load is not considered for this type of building. The fifth type of load is earthquake load. The inertia force created in the building by earthquake vibrations causes an earthquake load. Earthquake load is usually taken in a vertical and two horizontal directions. The movement in vertical direction do not cause forces in superstructure to any significant extent. It's mean that the vertical movement of the earthquake is usually neglected during applying earthquake load. But the horizontal movement of the building at the time of earthquake is to be considered while designing. Structures in seismically active places must be carefully analyzed and planned to make sure they would not collapse in the event of an earthquake. The sixth type of load is load combination. To guarantee the structure's integrity, building codes often provides a range of load combinations along with load factors. The following load combinations are described in standard code, that is DL plus IL, which means dead load plus imposed load. The other combination could be dead load plus wind load, and third combination could be dead load plus imposed load plus earthquake load. The fourth combination is dead load, imposed load, and temperature load. Okay, the question arises, why load combinations are important? These are important because as buildings and structures must withstand the heaviest storms, accidental events, and combined loading scenarios, engineers multiply load with safety factors and combine different loads in so-called load combinations to make sure the structure does not collapse. The sixth type of load is impact load or accidental load. Impact loads are rapid loads that are put on a structure for a short time compared to other loads that are imposed on a structure. Impact loads are created when heavy objects fall from heights or when live loads like moving cranes, cars, or machineries vibrate. This load might also be due to crashes, explosions, and fires. The eighth type of load is thermal load. As a result of temperature changes due to contraction and expansion, thermal load might be caused. They have the potential to apply considerable stresses to a structure. That's why it is important to consider thermal load while designing. Ninth type of load is earth pressure. The pressure that the soil applies in the lateral, or you can say horizontal direction, as you can see over here in the picture. The earth pressure needs to be considered whenever a structure holds back soil. This is the case for underground walls, retaining walls, sheet piles, metro stations, tunnels, and many more. The last but not the least, the 10th type of load is settlement, soil, and fluid load. The term settlement load refers to the phenomena that takes place when one section of structure settles more gradually than other sections. There is an excessive flow of water in the soil which affects the density of the soil. This is the cause of the soil and fluid load. So guys, that's all for today. I hope you have liked the topic. If it is so, then you are requested to please click the like button and don't forget to subscribe the channel so that you get the new uploaded video in time. That's all for today.